will, and then we'll move on to the next one. And that's kind of going to be our day. It's an unusual day where there really isn't a new concept for us to talk about, but there's some new problem types that I want to make sure you're familiar with. All right, here goes. A small used car lot carries an inventory of 20 cars. The mean value of the cars in this lot is $8,000. What is the sum of the values of the cars? At first glance, you might read this and go, okay, so you're telling me that there's this little car lot over there that has 20 cars and the mean value is 8,000. And you want me to tell you, like I'm an insurance guy, what's the value of all these cars added together? And your first thought might be, well, how the heck do I know? I don't know what any of those individual cars is worth. And that would absolutely be correct. Because what you'd like to do to get the sum of the values of the cars is to, if I knew the value of all the cars, I'd just add them up. We don't have that. But what we do know is we know that there are 20 cars, and we know that the mean value is $8,000. We also know one really important thing, and that is that the mean is equal to the sum of all the data points divided by the number of data points. And so this formula here that we don't really think about much because the mean is such a relatively comfortable idea for us. Yeah, add them up and divide by how many there are. You're right. Sometimes this formula comes in handy though. If we look at this one, what we've got here is this formula that has 3 pieces. And normally for us, we know these 2 pieces and we divide to find the mean. But the truth of it is, if we know any 2 of those 3 pieces, we can find the third one. And here in this particular case, we were told there are 20 cars, so we know how many there are. And we were told the mean was 8,000, so we know what the mean is. It's our job to find the sum. Okay, well, given that I have this formula here, if I know 2 of the 3 pieces, I can find the third piece, and that's exactly what we're going to do. All right, so let's see. I was told that the mean was 8,000. I'm looking for the sum, and there were 20 cars. I'm trying to get sum by itself. Essentially, now I have an equation that I'm trying to solve. What am I going to do here to get sum by itself? What am I going to do to get rid of this divide by 20 that's right there? Excellent. Natalie, Zara, Caitlin, thank you very much. We are going to multiply both sides by 20. That's exactly right. I'm going to multiply by 20 on the right. The reason I do that is to get these to cancel. We don't do a ton of algebra, so I'll kind of talk about those processes when we do algebra. And if I multiply by 20 on the right, I also need to multiply by 20 on the left. And when I do that, on the right-hand side, now I just have the sum. And on the left-hand side, I have 20 times 8,000. And that's 160,000. And so the sum of the values of the cars, which is what I was asked for, is $160,000. Now, I still don't know any of the values of the individual cars on the lot. Maybe every single one of them is worth 8,000. Unlikely, but not impossible. But what I do know is that if I added up all the values together, that it has to be 160,000. And I know that because I know how many there are and I know what the mean is. At first glance, when you first read this question, it can be really easy to be like, well, how in the world am I going to figure this out? Then it turns out that, you know what? If we think about the fact that I have the formula that involves the mean, I can actually solve this pretty easily. Are there any questions on that before I have you try one like it? And that's going to be our sort of our path today is we do one together, then I have you do one. All right, here goes. A liquor store has 315 bottles in stock. The mean value of the bottles is $42. What is the total value of the bottles? And I'll set up a poll for this. And what we want to know is the total value of all those bottles. This is a type of problem you can expect to see on homework, quiz, exam. And that's going to be true of everything today. So I definitely want you to practice. And if you're getting them right today, then you can feel really good about them. If there's anything you see that you're unclear about or doesn't make sense, as always, I want you to ask those questions. One thing that's important here is we don't know the value of any individual bottle. And that can kind of spin us around a little bit. Like, well, how am I supposed to know what they all are if I don't know the value of any of them? It's a reasonable question until you kind of think about it a little bit and then use the process that we're going to use to answer a question like this one. We'll go another 30 seconds and then we'll talk about it. And actually, I guess we can go a little longer than that. I can give you a little more time if you need it. We don't need to be in a hurry today. I don't anticipate today being a lengthy class session. All right, let's see where we are on this one. Not unanimous, but pretty close to it. All right, let's go take a look at how we'll work through a problem like this. So what I was told was that there are 315 bottles in this store and the mean value is $42. I don't know what any bottle is actually worth. There might not be a single one in the whole store worth exactly $42. But what I know is I know how many there are and I know the mean. And with that in mind, and knowing that the mean is equal to the sum over the number of data points, I can plug those in to my formula for the mean. Here I was told the mean is $42. And I'm looking, the total value, the sum, that's what I'm looking for. And then the number, well, there are 315 of them. I'm trying to get the sum by itself. So in order to get rid of that divide by 315, I'm going to need to multiply by 315 on the right and also multiply by 315 on the left. When I do this, these cancel. And now I have the fact that the sum is whatever 315 times 42 is. $13,230. So the inventory in this store is worth $13,230. I don't know what any bottle in the store is worth. I just know that if you add them all together, it would have to be $13,230. And just to sort of cement that home for a second, what we're saying here is that if I add all the values of the bottles together, I get 13,230. I know there are 315 bottles, so if I were to divide that by 315, I get 42, which is the mean, and this is how I would find the mean, and so it makes sense for 42 to be the mean here. Let me know if you have any questions on that before we look at a second type of problem. Well, I mean, we did multiply 315 by 42, but you know, you do want to make sure that you have your number of data points down here and your mean over here. If you reverse those, then that could definitely cause problems with if you are asked to calculate the mean of something or if you were asked a different kind of question. So make sure that you're putting the appropriate things in the appropriate places. We don't want to just the one thing that I would never want you to do is kind of look at this and go, well, there's two numbers in here. I'll just multiply them and see if that works. That's not a great strategy. Similarly, I wouldn't want you to go, well, there's two numbers in here. I'll just divide them and see if that works. Again, not a great strategy. Let's make sure that what we're doing with the numbers is based in some sort of logic that makes sense for the problem we're working on. We don't want to just take the two numbers in there and try something, because that might work sometimes, but I wouldn't be optimistic that it's going to work out all the time. Okay, let's look at another one. Josephine has taken 4 exams in her math class, and she has a mean score of 88. There's 1 exam remaining before her final grade is determined. What score will she need on the last exam in order to finish the class with an overall mean of 90? Now, this is something that, in my pie in the sky dreams, I think every student does it. They look and see, like, where am I now? What do I need on the final exam in this class, the last exam in this class, to get the grade I want? Maybe you're somebody who does that, maybe not. It's okay. But here Josephine she's taken 4 exams and she has a mean score of 88. And there's 1 exam to go. And we want to know, what does she need on that exam to finish with an overall mean of 90? Now, one thing, before we do any work at all, right now she has a mean score of 88 and she wants to finish with a mean of 90. So right away, before I do anything, I know she's going to need a pretty high score here, right? Because right now she's got an 88 and she's trying to improve her grade, pull it up to 90. So the answer I get here better be bigger than 90. Outstanding, Edison. That's excellent. Perfect. Yeah, it's got to be, because she's trying to pull her grade up. Very good, Edison. That is excellent. Okay, so this is another one that you can see that the mean is mentioned in the problem. That doesn't always necessarily tell us that we're going to use the formula for the mean here, but we know that the mean is equal to the sum of the scores divided by the number of scores. We're going to put that to work for us here. We're going to look at what Josephine has done so far. So far, let's see, Josephine has a mean of 88. So I know that the mean is 88 for her. And then she has taken 4 exams. So I know that there have been 4 data points. And so what I can find is I can find the sum, and what the sum represents here is that's how many points she's earned so far in the class. So what this sum represents is important for us to keep track of. In the previous problems, it was sort of the value of the cars or the value of the liquor bottles. In this one, this sum represents the number of points she's earned so far. Just like we did before in finding the sum here, we're going to multiply by 4 to get those to cancel. If we multiply by 4 on the right, we'll multiply by 4 on the left. And what we find out then is, let's see, 4 times 88. So far, Josephine has earned 352 points. Let me know if there's something there that you're not sure of. If that's comfortable and good, then we're going to look at the other half of this question, which is, okay, well, that's the point she has so far. What is it she wants to have? What she wants to have, well, let's see. She wants to finish with a mean of 90. So let's go ahead and put that in. She wants a 90. We don't know how many points that's going to be. And here's an important part of this question. What number is going to go down there? Okay, interesting. So 352 is how many points she's earned so far. Remember what the formula for the mean tells us. It's the sum of the data points divided by the number of data points. So it's the sum of those data points divided by the number of data points. All right, we got a couple of different options here. So here's the thing. In this calculation over here, her mean was found by All right, if I knew how many points she earned and I divided by 4, I would get the mean because she's taken 4 exams. When we're over here in this future, now she wants to have a mean of 90, and this is going to be the number of exams, right? Because how many points has she earned divided by how many tests has she taken to get that average or mean, excuse me, of 90. So with that in mind, let me try that again here. If I was going to get her mean score for all the exams she's taken at the end of the class, we would need the points she earned all together divided by what number goes down here now? All right, Escadar switched from 4 to 5. Natalie had a 5. Edison's got a 5. That's excellent. Right. Now she's taken that one more exam. So what happened at this point over here is she had taken the first 4 exams. She's going to take one more exam. And so after she takes that one more exam, now if we wanted to find her mean, we would need the total number of points she's earned divided by 5. Really important part of a problem like this is she's going to take one more exam. So the number of exams taken has to go from 4 up to 5. And now what we can do, because we know the formula for the mean is we'll multiply both sides by 5. That'll get these 5 to cancel. And then we can see that the total number of points she needs is 5 times 90, which is 450. And so this is the points she needs. One more step for us to do here, and that's this. Right now, the points she's earned so far is 352. She's going to need to end up with 450 points. Excellent, Edison, you've got it. So we're going to take that 450 that she wants and subtract the 352 that she already has and find out that on that last exam, Josephine's going to need a 98. It makes sense that she's going to need a really high score because she's trying to bump her grade up from 88 to 90. I'm with you, Edison, but hey, if she prepares, she can do it. So she's going to need 98 on that last exam in order to finish with an overall mean of 90. Let me know if you have questions before we try one. Okay, here goes. Carmen has taken 8 quizzes in her English class, and she has a mean score of 72. There's 1 quiz remaining before her final grade is determined. What score will she need on the last quiz, spelled wrong, sorry about that, in order to finish the class with an overall mean of 70? So right now, Carmen's got a 72 after 8 quizzes. She wants to have a 70 after 1 more quiz. What's she going to need on that last quiz? I'll make a poll for this one and let you try it. This is another one that at first glance you might not think formula for the mean, but we know her mean and we know how many she's taken. When that's the case, we can find out the sum, which in this scenario means the total number of points she's earned. It also means the total number of points she's going to need to finish with to get the grade she wants. We can go another 20 seconds on this and then talk about it together. Let me know if you need more time. And definitely the type of question you could expect to see in quiz, homework, possibly on an exam. Everything we see today would fit that category or that sort of description, I guess. All right, let's see how we're doing on this one. Okay, not unanimous, but strong agreement. Strong agreement is good. Not unanimous means let's make sure we're patient and careful as we go through this description. So let's talk through this a little bit. Carmen's taken 8 quizzes. She has a mean of 72. There's 1 quiz remaining before her final grade is determined. And so since this mentioned the mean, what we can kind of lean into is that the mean is the sum of her data points divided by the number of data points. And the first thing we want to start off with is, okay, well, where is Carmen now? So far in this class, she has a mean of 72. We don't know how many points she's earned. We have no idea what any of her individual quiz scores are, but that's okay. We can do this because we're going to find out how many total points she's earned so far and divide by the number of quizzes she's taken, which is 8. Her mean would be how many points she's earned divided by 8. That's how we're going to get this 72. The thing is, we don't know how many points she's earned, at least not yet. So to get sum by itself, we're going to multiply by 8 on the right, multiply by 8 on the left. These are going to cancel, which is what we needed to have happen so that we would get sum by itself. And so 8 times 72. Hey, thanks, Escadar. You saved me the calculator there. I didn't look up fast enough. Thanks, Liza. Is 576. This is how many points she's earned so far, which is a great thing for us to know. We know she's earned 576 points so far. What she's trying to do is finish with a mean of 70. So what she's going to need is she wants a mean of 70. We don't know how many points that's going to take just yet. And the key part of this problem, where you'd make a mistake if you made one, is right here. And that's she's taken 8 quizzes so far. There's 1 more to go. So after that one, she will have taken 9. That's right, Escadar. Exactly. So now she's taken 9 after she takes that 1 more quiz. Okay, we're going to solve this and find out the sum. And the sum here is how many points is she going to need to have a mean of 70? So we'll multiply by 9 on the right. We'll multiply by 9 on the left. Those will cancel. And let's see, I've got the sum. And 9 times 70 is 630. Yep. And so the points she's going to need, if she wants to end up with a mean of 70, she better have 630 points after that last quiz. Because what her instructor is going to do is her instructor is going to say, well, let's see. She's got 630 points divided by 9. That's a mean of 70. So she better have 630 to make that happen. All right. So she has 576. She needs 630. So in order to bridge that gap, in order to get from 576 to 630, we'll just subtract and figure out how many she needs. And that's 54. So she's in pretty good shape. She only needs 54 points on the last quiz to end up with a mean of 70. We'll talk about weighted averages next week, but what's going on here is over the course of 8 quizzes, she's got a 72 in the bank. That's a lot of quizzes with that 72 average. So it's going to be hard to mess it up on one quiz. She's got some cushion built in, and the cushion allows her to get a 54 on that last quiz. Not a problem, Escadar. It happens sometimes. And heck, sometimes you just hit the wrong button on the screen. So I totally get that. The main thing is if you can see why you didn't have the right response, that's perfect. Whether it's something simple like not reading it correctly or hitting the wrong button, or something that's involved in how we're trying to solve it. And I didn't understand what to do, but now I do. Anytime you get to the place where I totally get it now, that's perfect. Very good. Yeah, I agree, Nicole. Well, and that's the thing, right? If you build yourself up, if you over the long term build yourself up a cushion, when it gets to the end, it's kind of nice to have that cushion in place. All right. Any questions on this before we move on to a different one? Terrific. Okay. A morning section of a class consists of 18 students, and their mean score on an exam was 88. An afternoon section of the class took the same exam, and those 24 students earned a mean score of 81. What was the overall mean score for this exam? So this instructor has a morning section and an afternoon section. Morning class had a mean of 88. Afternoon section had a mean score of 81. And the instructor wants to know, what was the overall mean? What I would not want you to do here, what you definitely shouldn't do here is go, well, I'll just do 88 plus 81 divided by 2 and figure out what that is. The reason we don't want to do that is because these classes don't have the same number of students in them. There are 18 students in the morning section. There are 24 students in the afternoon section. So because the afternoon class has more students in it, we need to make sure we take that into consideration when we calculate the overall mean. So what we're going to do with this one is we're going to put a frequency table to work for us. We are going to have the test score on one side and the frequency on the other. And so in that morning class, the score on the exam was 88, and there were 18 students. So the frequency is 18. Now, it doesn't mean that every single student in the class earned an 88, but because we know that was the mean score, we want to give it this much weight. We want to count that 88 for 18 students. If I want to know how many points were earned, it would be 88 times 18. And so I could sort of, in this calculation, looking for the overall mean, I can just sort of in my head, okay, it's the same thing as if every one of them had gotten an 88. And then we have this mean score of 81, and the frequency for that was 24 because 24 students earned that score. So this is a problem that doesn't necessarily read like I could put this in a frequency table right away. But once you kind of step back and think, hey, wait a minute, I have this data point 18 times and I have this data point 24 times, which means I can use this frequency table. And now all we're doing is finding a mean from a frequency table, which is something we did on Tuesday. The key here is recognizing, hey, because I have a data point that occurred a whole bunch of times and another data point that occurred a whole bunch of times, I can put this into a frequency table and then find the overall mean. I'll go ahead and find the overall mean here. That's going to be, let's see, there are 18 scores that are 88. There are 24 scores that are 81s. And a really important number here, I'll give you a chance to tell me, what am I going to divide by down here? How many data points do I have? And be careful with this one. Based on what we did on Tuesday, I definitely don't want you to say 2. Awesome. 42. Thank you, Genesis Social, Nicole. Perfect. 42 data points. So we're going to divide by 42 because the number of data points we have is the sum of our frequencies. All right. So then here we'll have, let's see, 18 times 88 is 1,584. If you're thinking, what in the world does that number even mean? 1,584. Well, that would be the sum of all the exam scores from the morning class, because I'm doing 18 times 88. I don't know what any of the individual exam scores are, but I know if I added up all those exam scores, the total number of points earned would be 1,584. Same thing happens when we do 24 times 81. I get 1,944, and that's a weird number in this question. But again, what that is that's if I took these 24 exam scores and added them all up, I would get 1,944 points. And then we'll divide by 42, and let's see what we've got here. So plus 1,584 is 3,528 divided by 42. And that's 84. So the question was, what was the overall mean score for the exam? And it was 84. Let me know if you have any questions on what we did there before I have you try one. My expectation is this one will go great because you're probably pretty comfortable with frequency tables right now. But this is great practice. Okay, here goes. The freshman class at a small 2-year college consists of 530 students, and their mean GPA is 3.6. At the same college, the sophomore class consists of 305 students, and their mean GPA is 3.0. What's the overall GPA for the students at the college? So there's only, it's a 2-year college, so there's only freshmen and sophomores, that's it. And we know what our freshman GPA is and how many there are. We know what our sophomore GPA is and how many there are. So what's the overall GPA for the students at the college? I'll set up a poll for this one and let you try it. And those are rounded to the nearest hundredth. I didn't mention that in the problem, but you can see in the poll, everything's been rounded to the nearest hundredth. My expectation with these is the challenging part is recognizing that this is a frequency table type setup. But where that comes from is the idea that, well, I've got a data point that occurs a whole bunch of times. That's what kind of points us towards frequency table for this one. I'm thinking we'll go another 30 seconds and then talk about it. If you need more time, just let me know. All right, let's see where we are on this one. Again, strong agreement, not unanimous. Strong agreement's a good thing, and we'll just kind of make sure that we're going through it. If you see anything that you're not sure where it came from or why we did what we did, please make sure you ask about it. So what we'll do here is we'll go through here and we'll see, all right, there's 530 students that had this GPA, and there's 305 students that had this GPA. So I have this data point here that occurs a whole bunch of times. And I have this data point that occurs a whole bunch of times. That sets up nicely for a frequency table where my data points are these GPAs, and the frequency is how many people have that. And so let's see, the freshman class had a 3.6, and there were 530 students involved. Now again, I don't know what any individual student's grade point average is. I just know that if I were to find the mean of all of them, 530 of them would have this mean of 3.6. And then 3.0 GPA, it goes with these 305 students. And now I want the overall GPA. Well, that's perfect because I look at this and I can see really important number when I go to find the mean is the total number. And 530 plus 305, let's see, that's 835. So I have 835 data points. Unusual for us to have a data set with that many in it. Definitely wouldn't want to write them all down individually, but we're good with this. So we'll go ahead and find our overall GPA here. And that's going to be the overall mean, but our overall GPA here is then going to be, let's see, there are 530 students that have a 3.6, and there are 305 students that have this 3.0. And all together, there are 835 students. So I'm going to find the mean here. And let's see. 530 times 3.6 is 1,908. And then 305 times 3.0 is 915. And I'll need to divide by 835. We'll add those together. 2,823 divided by 835. And we have rounded to the nearest hundredth, 3.38. What's important to note here is that we didn't just say, well, I've got 3.6 and 3.0, so halfway between those is 3.3 and we're done. Well, we don't do that because we don't have the same number of students in each class. By backwards, do you just mean that these were switched? Because if that's true, Escadar, that would be just fine. Not a problem at all. Yeah, totally fine. That's exactly the same. If you had these the other direction with the 3.0 on top and the 3.6 on the bottom, totally fine. Basically, we just want to make sure that, that we're looking at, we have this GPA this many times, this GPA this many times, and that we're going to multiply the proper things together. But it doesn't matter which one you have first. You're okay if you have those reversed. Great question. Very good question. Okay. Any more questions about this before we look at another type? Yeah, absolutely. No, I want you to ask questions whenever you have them. You did the right thing. Okay. Okay. The mean of a set of 8 numbers is 11. If one number is taken away, the new mean is 12. What was the number? Your first instinct here might go, well, I don't know, it went from 11 to 12, so is it 1? It's more involved than that. So please don't look at it from that standpoint. Here again, I'm told of something about the mean. I'm also told that there were 8 numbers. So I know the mean, I'm told how many numbers there are. Seems to me like we're going to have this thing come into play again. The mean is equal to sum divided by the number of data points. And when I first mentioned it on Tuesday, you might have thought, well, what am I ever going to use this for? It's just add them up and divide how many there are. Well, sometimes when the problem's a little complicated like this one, this formula sure does come in handy. And here's a case where it's going to come in handy for us. So let's take a look here. The mean of a set of 8 numbers is 11. If one number is taken away, the new mean is 12. All right. Now, you may not see it right away, but this is going to be a lot like when we did Josephine's test scores. Because right now, I've got this mean of a set of 8 numbers. Let's see, I'm told that the mean is 11. Okay, so the mean is 11. I don't know what these numbers add up to, but I know that there are 8 of them. If any of these numbers that I just put in there don't make sense, you let me know. Like, where'd you get that 8 from? For example, well, I was told that there are 8 numbers. Remember, the mean is add them all up, divide by how many you have. And how many we have is the 8. So that's why that went where it went. So the mean of those 8 numbers is 11. Okay, great. Well, if I know that, I can find the sum. So if I multiply the right by 8 to get these to cancel, I need to multiply the left by 8. And so now what I have here is 88 must be the sum of all these numbers. I have no idea what any individual number is. That's okay. I don't need to. I just know if I added them all up, I'd get 88. All right, now there's going to be this new thing where I'm going to take one of these numbers away. When I take a number away, the new mean is 12. So the mean's going to be 12. I don't know what the sum is going to be. And here it is. Here's the big question. What number goes down here? How many data points do I have now? Very good. Edison, Natalie, Riley, Escadar, perfect. I used to have 8. I took one away. Now I have 7. Very similar to what we did with Josephine's test scores and Carmen's, I guess, but we're kind of going the other direction. Now instead of adding one on, we're taking one off. Okay, so I can find the sum of this new data set. In order to do that, I'm going to have to multiply by 7 on the right so that these cancel. I'll multiply by 7 on the left. And when I multiply those together, what I'm going to have is 84 is the sum. So originally, the data set I had added up to 88. I've taken a number away, and now it adds up to 84. So the number that must have been taken away to get me from 88 to 84, you could do the subtraction. This one you could probably do in your head, but the number that was taken away then must have been a 4. Perfect, Riley. Very good. Very good. Are there any questions on this before I have you try one? This is one that at the very beginning, when you first read it, it's like, I don't know. Am I going to trial and error this thing? What the heck am I going to do? But if we lean back into this formula, it's a really cool problem that's kind of fun to solve, I think. All right, here goes. The mean of a set of 10 numbers is 43. If one number is taken away, the new mean is 39. What was the number? I'll set up a poll for this, and I'll let you try it. and kind of like everything we've worked on so far today. This is one of those, when you first read the problem, it might not be obvious what to do, but then, wait a minute, I've been told something about the mean in every one of these questions. So it's the formula for the mean that I want to take advantage of here to help me solve it. So while it might not seem obvious what to do, the idea that the mean is brought up helps us decide, well, I'm going to use the formula for the mean and just kind of see where that leads me. And it will lead you to the right place. There's a little bit of problem solving skill and a little bit of logic involved in, okay, now I've got the formula for the mean, what am I going to do with it? There's a little bit of that, and practice helps, repetition helps, and also just sort of making sure you understand what you're being asked for. And again, practice is sort of how that becomes much more comfortable. Let's go another 30 seconds, and then we'll talk about this one. Again, absolutely the kind of question you can expect to see on homework, quiz, exam. Let's see how we're doing. Okay, not unanimous, but strong agreement. That seems to be our sweet spot, is not unanimous, but strong agreement. If you see something in this explanation that you're not sure of, doesn't make sense, you let me know, and we will make sure to get that cleared up for you. So let's see, the mean of a set of 10 numbers is 43. There's something about the mean going on here. So the mean is the sum of the data points divided by the number of data points. I'm going to keep that in mind as I go through this. And so right now, what I've got is a data set that has a mean of 43. I don't know what the sum is, but I know there are 10 numbers. So whatever it is, if I add them all up and divide by 10, I get 43. That's what this sentence tells me. If I add them all up and divide by 10, I get 43. And that's what this equation tells me. So we want to find the sum here. So in order to do that, I'm going to multiply by 10 on the right, because I want those to cancel. Multiply by 10 on the left. What that does for me is lets me know that 430 is the sum of those 10 numbers. All right, very good. Hey, Riley, it's really important that I let y'all know. If you see me do a problem and you see, oh, okay, now I know where I made a mistake, that's really good and really valuable. Even better than that, when you recognize what your mistake was, that means you really understand it. So it's great if when I'm working through it, you go, oh, that's what my mistake was. That's really good. Even better is when you go, I know what I did wrong. And that means you've got a handle on things. So excellent, right? That's good. All right. So this new data set that I'm going to have here now, the mean is going to be 39. And instead of having 10 numbers, I'm taking one away. Now I'm only going to have 9. So I don't know what the sum is going to be, but there's only going to be 9 of them. All right. So to find the sum of those numbers, multiply by 9 on the right so that those cancel. Multiply by 9 on the left. And then what we end up here is 9 times 39. 351 is equal to the sum. So in my old data set, when I added up all the numbers, I got 430. In my new data set, when I add up all the numbers, I have 351. Well, what is it that was in there that got me from 430 all the way down to 351? I don't know, but if I subtract, I'll find it, and that's 79. So the number that was taken away, very good, Stephanie, Liza, excellent, must have been 79. If anybody has questions on what we worked on there, you let me know. Otherwise, we have one more problem to work on. I think I've kind of saved the most challenging for last. Maybe that's good news, maybe it's not, but let's go ahead and take a look at it. Kenny took 3 tests. The mean of his scores was 83, the median score was 86, and the range was 21. What were his 3 scores? All right, so let's make sure we get a handle on this here. So Kenny took 3 tests, and we know the mean, and we know the median, and we know the range. So we've been given a whole bunch of stuff here. We've been given the mean, we've been given the median, and we've been given the range. And what we're asked to find are what were his 3 scores. And you could label these as 1, 2, and 3, but I think better than that here, I think what we want to do is label them as high, middle, and low. Because he took 3 tests. Now, maybe some of them had the same score, but let's go into this with the idea that he had a highest test score, a lowest test score, and one that was in the middle. I'm going to ask you right out of the gate here, what was his middle test score? And if you're thinking, how the heck am I supposed to know? Read the problem again and you'll get it. Very good. Escadar, Riley, Xochitl. Perfect. I was told right here in the question that the median was 86. There's only 3 of them. So the median's the one in the middle. So his median score, his middle score was 86. Okay, I've already got a handle on this thing. I was asked to find 3 scores and I've already got one of them. I'm doing pretty good. All right, now what I need to do is I need to figure out how to find this high score and this low score. I was told that the range is 21, so I know the difference between those is 21. So that's good. I've got that sort of in the back of my mind here, that the difference between the high and the low is 21. So that's how the range is going to come into play. And the thing we haven't used yet here is this mean of his scores was 83. If you're going to give me the mean, I'm going to lean back into this formula for the mean. And in this particular case, I know he took 3 tests and I know the mean was 83. So here again, just like we've seen kind of all day long, I know the mean, I know how many there were, so I can find the sum of his test scores. All right, so let's see here. If the mean, I know the mean was 83. And I don't know the sum, but I know there were 3 scores. So I'm going to multiply both sides by 3 and find out that the sum of his test scores is 249. Everybody with me so far? Anybody have any questions at this point? That the sum of his 3 test scores has to be 249. Thanks, Edison. That's awesome. Okay, so the sum of his test scores is 249. Well, that's great, but I only know one of them. I don't know the other 2. So I could do some trial and error here to try to make this happen. And, trial and error isn't a terrible thing. First, though, if I know that they all 3 add up to 249 and I already know one of them is 86, if I subtract that 86 off of here, so 249 minus 86, I get 163, and that's the highest plus the lowest. If I add all 3 together, I get 249. If I take this 86 out, then highest plus lowest has to be 163 points. If that doesn't make sense, you let me know. So highest plus lowest is 163, and the range is 21. So these 2 have to add up to 163, and the difference between them has to be 21. Now, you could use trial and error at this point. You could say, well, they have to add up to 163 and the difference has to be 21. So I don't know, what if they're like, 85 and 70, what would it be, 78? Okay, that gets me my 163, but it doesn't get me the range of 21. And you could trial and error your way through that. What would I like better? Not quite, Edison. I think that would be too big of a number. What I like better than trial and error here, trial and error is okay, but what I like better than trial and error is this. If I know that the highest plus the lowest is 163, And because I know the range is 21, I know that the highest minus the lowest has to be 21. I'm not sure about that. I'm not sure about that one. We'll see how this plays out. What I do know for sure is highest plus the lowest is 163. Highest minus the lowest is 21. Now I have two variables and two equations. This is like, if you remember from Math 122, pigs and chickens, if you remember from the first week of our class, the problem about you were on a game show and you get $5 for every correct answer and you lose $2 for every incorrect answer, two equations and two variables. What we're going to do is we're going to use substitution here. In this bottom equation right here, I'm going to add L to both sides. These are going to cancel, and now I've got H is equal to 21 plus L. So H is 21 plus L, and now I'm going to substitute. I'm going to take this 21 plus L, and I'm going to substitute that in for H in the other equation. What that's going to give me, and I've kind of scrunched myself on space here. So give me just a second to rewrite some stuff over again here. I apologize for this little short pause, but we'll get right back to where we were. We knew that H plus L was 163 and H minus L was 21. We added L to both sides in that bottom equation. Those canceled, and we found out that H is just 21 plus L. And then I can take that 21 plus L and substitute it in for H in the top equation. What that gives me then is a new equation that instead of H, I'm going to write 21 plus L is 163. And now I have an equation that I can solve for L. Because now I can add these two together, and I have 21 plus 2L is 163. Now I want to get L by itself. A little bit of algebra here. We're going to have to do some review. I'm trying to get L by itself. So I need the term with L by itself. So as I look at this side of the equation, I want to peel that onion from the outside in. The first thing I want to do is get rid of that 21. What step do I do to get rid of that 21? Excellent, Genesis. Thank you very much. We're going to subtract 21 on the left and subtract 21 on the right. These will cancel, giving me 2L is equal to 142. And then one last step to go. In order to get multiplication to go away, I'm sitting here at 2L equals 142. In order to get multiplication to go away, I need to divide by 2 on the left, divide by 2 on the right. Those will cancel, and I get that L is 71. Very good, Nicole. Now I know what the low score is. Low score is 71. How am I going to find out what the high one is? Excellent, Nicole. Very good. Well, I found out over here just a couple minutes ago that the high one is 21 plus the lower. Once I know the low one is 71, all I need to do is add 21 to that. And so I'll do 71 plus 21, and the high is 92. And now I have all three test scores. I can see by looking at them really easily that the range is 21. I can see that the median's 86. And then if I wanted to just double check my work here, I could add those up. 92 plus 86 plus 71 divided by 3. Sure enough, the mean is 83. So I know I'm right because I met all the conditions. The mean's 83, the median's 86, and the range is 21. So I'm positive I have the right three test scores. I don't think that's an easy question. There's a lot to do there. No one individual step by itself is that hard. There's just a lot to keep track of. And we did do some algebra over here. You can find these by trial and error instead if you want to. That's okay. Um, oh yeah, well, those would be the same steps we did over here, just in a different order. But I mean, you can see we did 163 minus 21 to get here, and then divided by 2 to get to 71. So those are the exact same steps, Edison. All right, I'm going to let you try one of these. And this will finish us off for today. I'm going to have you try one like this. Peyton took 3 exams. The mean of his exam scores was 90. The median was 89, and the range was 11. What was his highest score? I'll set up a poll for this and let you try it. This, these take the longest of all the problems we've looked at today because there's kind of a lot to do. We want to lock in that median as the middle, recognize that we have the mean so we can find the sum of the scores, and then we know the range. And we can figure out highest plus lowest, highest minus lowest, and then from there, we can figure out the 3 scores. Or I guess the other 2. We were given the middle one. I remember I told you at the beginning of the semester that, I hadn't done 123 as a remote class before. And there'd be some days where it was shorter than I thought, and some days it would be longer than I thought. I honestly thought today would be a really short one, but I've liked the pace we've gone at. I thought we'd finish really early today, and we're going to use up all the time, which is great. These are questions that I think might be really hard to do if we didn't talk about them. So I'm really glad we've had a chance to talk about them. And now I know that what we worked on today, it's a full class. So that's good information for me to know. You guys are great with the polls, so I think you're going to do really well with the homework, which is terrific. I don't want to cut you off, but I think we'll go another 20 seconds on this one, 25 seconds, and then we'll start working through it. I just want to make sure we have a chance to finish it and then leave a little bit of room if somebody has anything they want to bring up. So you may not have had a chance to finish this one. There aren't as many responses as typical, but that's okay. When we start working on it, you go ahead and finish. Look at what we're doing, look at what you're doing, and if anything doesn't align, you make sure to ask about it. All right, let's see how we did. Okay, good. Again, almost unanimous. Oops, that's really good. All right, so let's work through this one, and we'll do it a little more quickly than we did the last one. We're after 3 test scores here. We're going to have the highest, the middle, and the lowest. And we're told that the median score was 89. So right away, we know the middle score is 89. We've got that one for free. All right. I'm also told that the mean was 90. Okay, and there were 3 exams. So what that means is that the mean was 90. I don't know what the sum of the scores was, but there are 3 exams. So we can multiply those together and find out that 270 was the sum of all 3 scores. Since we already know the median, we can subtract that off and find out that the sum of the other 2 scores must have been 181. That's high plus low. Now we can set up our 2 equations. I know that the high score plus the low score had to be 181. And because the range is 11, the high score minus the low score had to be 11. This is where substitution comes in. If I add low to both sides, oops, those cancel, and I found out that the high score must be 11 plus the low score. And that makes sense, right? The range is 11. So if I took the low and added 11 to it, it would give me the high. So that makes sense. Now I take this 11 plus L, because it's the same thing as H, I can take that and put it in here where the H is. And so now instead of H, I'm going to put 11 plus L. There's plus that other L makes 181. Essentially what I've said here is high plus low is 181. Now we just need to solve this for L, and we'll have our low score. So I've got 11 plus 2L is 181. We'll subtract 11 from both sides and get that 2L is 170. Divide both sides by 2 and find out that L is 85. So now I know that the low score is 85. And if I add 11 to that, I get the high score, which is 96. And I've got all 3 exam scores. The poll asked, what's the high score? And that's the 96.